The Indian media claimed that without the key equipment provided by India, the Chinese space station would be useless. Let's take a closer look in this video. On May 10, 2023, China's Tianzhou-6 cargo spacecraft was launched and successfully docked with the Chinese space station. Tianzhou-6 is one of the spacecraft with the strongest cargo capacity in the world. But what is puzzling is that the China-India cooperation project Nebula Gas Spectroscopy Research Project that was supposed to be launched on this mission did not appear in the task list. It was later confirmed that the reason why the project could not be implemented was due to the technical blockade implemented by the Indian Ministry of Foreign Affairs. The Indian media commented on this: without India's cooperation, the Chinese space station would be just an empty shell. Are collaborative projects in India really that important? Why does the Indian government want to confront China in the space field? The United Nations Committee on Outer Space once made a famous conclusion: developing space technology is a shortcut for developing countries to catch up with developed countries. India is convinced of this. As early as 1947, Indians founded the now famous Indian Physical Research Laboratory of India. In 1963, India successfully launched its first sounding rocket. In 1975, India launched its first independently developed satellite with the help of Soviet rockets and launch sites. 5 years later, India successfully launched its own SLV-3 rocket and sent an experimental satellite into outer space. At that time, India's economic situation was very severe, and the Sriharikota Space Center that performed the launch mission was developed from a small fishing village. Many rocket and satellite components are transported to the launch site on ox carts and bicycles. Even so, India has never interrupted the research and development process of space technology, which is admirable. After entering the 21st century, India's pace of exploring space has slowed down, but it is still proceeding in an orderly manner, with new highlights from time to time. In 2008, India used a PSLV-C9 rocket to launch 10 satellites into space, becoming the 5th country after the United States, Russia, Europe, and China to master multi-satellite technology with one rocket. In 2013, India achieved a leap forward in the field of Mars exploration, sending the Mangalyaan Mars probe into space. The detector weighs 1.35 tons and is equipped with 5 detection instruments. On September 24, 2014, the probe successfully entered Mars orbit, marking India becoming the 4th country to successfully conduct Mars exploration after the United States, Russia, and the European Union, and the only one to reach Mars on the first try. Despite economic difficulties and technological backwardness, India has still achieved an early start and continuous breakthroughs in space exploration. After the improvement of economic conditions, India's aerospace technology still maintains a rapid development, which is enough to show the importance Indians attach to outer space. It is a pity that in the new historical period, the mentality of Indians has changed. After entering the 21st century, China's aerospace technology has developed rapidly, constantly surpassing India. As China successively achieved manned spaceflight and lunar exploration, the mentality of Indians began to become unbalanced. In 2007, Chang'e 1 was successfully launched and successfully merged into the lunar orbit, and then India also accelerated the process of exploring the moon. The Indian lunar exploration plan is divided into 3 steps: first realize the flight around the moon, then achieve a soft landing, and finally send astronauts to the moon. On October 22, 2008, India followed China by launching their first lunar probe, Chandrayaan-1. Chandrayaan-1 has made a lot of progress, such as the discovery of a large amount of magnesium, aluminum, and calcium elements on the surface of the Moon, and the discovery of the complex water cycle process on the Moon. But in August 2009, the directional navigation function of Chandrayaan-1 suffered a serious failure, and finally lost contact with the ground station. It was not until 10 years later that India restarted its lunar exploration program. On July 22, 2019, Chandrayaan-2 was launched into space. In the following month or so, Chandrayaan-2 sent back a large number of photos and data, and successfully carried out multiple orbit changes. But the new lunar exploration program is only one step away from success. On September 7 of that year, ISRO announced that contact with the lander had been lost just 2.1 kilometers from the lunar surface. The Indian Space Research Organisation later confirmed that the speed of the lander was not effectively controlled as early as the initial stage of the landing operation, which led to the crash of the lander. After the failure of Chandrayaan-2, the capabilities of the Space Research Organisation were called into question, and budgets for lunar exploration were slashed. However, seeing China's successive soft landings and moon sampling, the Indians' competitive psychology has never been satisfied. As early as the beginning of 2020, the Indian government approved the latest Chandrayaan-3 plan. After several delays, the launch plan of Chandrayaan-3 was more than 2 years later than scheduled, and it was not launched into space until July 14, 2023. According to the plan, the Lunar Vehicle 3 probe must first enter an orbit with a perigee of 170 kilometers and an apogee of 36,500 kilometers, and then gradually approach the Moon. However, NASA's observations show that the actual orbit of Chandrayaan-3 is an orbit with a perigee of 138 kilometers and an apogee of 36,306 kilometers. This means that Chandrayaan-3 has seriously deviated from its planned trajectory from the beginning. As for the cause of the orbit deviation, the Indian Space Research Organisation has put the blame squarely on China. Some say that Chandrayaan-3 was maliciously interfered by Chinese satellites, and some say that Chinese materials were used on Chandrayaan-3. China has inexplicably become the target of India's blame, but everyone knows that India just can't find any reason this time. In fact, the reason why Chandrayaan-3 deviated from the orbit was due to its own design. Although the Indian Space Research Organisation has repeatedly claimed that Chandrayaan-3 is equipped with India's most powerful rocket, the geosynchronous transfer orbit capacity of this LVM-3M4 rocket is only 4 tons, and the Earth-to-Moon transfer orbit capacity is only 2 tons. It is inevitable that such a detector will not be able to perform its tasks well. The Indians are well aware of their own lack of power, so it will take a full 40 days for Luna 3 to take off and enter the lunar orbit. But they didn't expect that this problem would have such a serious impact from the beginning. Fortunately, after this turmoil, there were no abnormalities in the follow-up plan of Chandrayaan-3. As early as 2006, India announced its own manned space program. But more than a decade later, the plan remains on paper. On the other hand, China has not only sent astronauts into space many times, but also built its own space station. On April 29, 2021, Tianhe, the core module of the Chinese space station, lifted off from the Wenchang space launch site. The Tianhe core module has 5 interfaces, 2 of which are used to connect to the experimental module, and the other 3 are used to dock the Shenzhou manned spacecraft, Tianzhou cargo spacecraft, and other aircraft. In the following more than a year, the Wentian experimental module and Mengtian experimental module were successfully connected to the Tianhe core module, and the Shenzhou spacecraft and Tianzhou spacecraft also sent personnel and materials to the space station many times. With the steady development of China's space station program, many countries have extended an olive branch to China, hoping to reach cooperation. In June 2019, the China Manned Space Engineering Office announced that 9 cooperation projects had been identified from 42 applications. The projects came from 23 institutions in 16 countries, of which 6 were fully adopted and 3 were conditionally adopted. The spectroscopic study of nebular gases (SING) project from the Indian Institute of Astrophysics is one of the 6 projects that has been fully adopted. This project was developed by Murthy of the Indian Institute of Astrophysics. The main device includes telescopes, spectrographs, and other equipment, with a cost of $50,000 and a design life of half a year to 1 year. Its main function is to study the composition and changes of interstellar gas. According to the agreement, the experimental device will arrive in China in November 2022 and be transported to the space station by the Tianzhou 6 spacecraft in 2023. However, when the agreed time came, India still failed to deliver the equipment, and even after repeated urging, it still failed to fulfill its promise. As we all know, Tianzhou 6 has launched into space on May 10, 2023, which means that the cooperation between the 2 countries has ended in failure. After the cooperation fell through, many people were curious about why India was reluctant to fulfill the cooperation agreement. It was not until August that the Hong Kong newspaper South China Morning Post revealed the reason. It turned out that Murthy's team had completed the final assembly of the equipment 2 months before the agreed time, and had strong expectations for the cooperation between the 2 parties. But shipment of the equipment to China requires an export license from the Indian Ministry of Foreign Affairs. Due to the tense diplomatic situation between the 2 countries, the Indian Ministry of Foreign Affairs was reluctant to issue an export license, which led to the failure of the cooperation. Subsequently, the Indian media AC News published an article describing the incident as China urgently needs India to provide SING equipment. Otherwise, the Chinese space station will be useless. Such articles greatly satisfy the vanity of Indian society, but is this really the truth? According to the cooperation agreement, China will send equipment from various countries to the space station for free and conduct experiments in strict accordance with the requirements. Afterwards, each country will receive experimental data for free. This move will greatly save the research funds of various countries and reduce the difficulty of experiments. This is one of the reasons why they are so interested in space station cooperation. As Murthy said, if the launch costs were not borne by China, his R&D expenses would far exceed budget constraints. The study of nebula gas is no longer the cutting-edge technology. As early as the 18th century, German scientists had already achieved the measurement of the solar spectrum. A $50,000 project, this technology may still be difficult for other countries, but for China, it is a piece of cake. There is probably no need to say who the Indian government has lost due to its obstruction. Thank you for watching. If you enjoyed this video, don't forget to like, comment, and subscribe to our channel for more great content. See you next time.